Now let me solve a problem to find the value of a function if I have the Fourier series in a full range. Example: find the Fourier series of pi minus x to the whole square over 2 in a range from 0 to 2 pi. Here I don't want to talk about the even and odd functions. I'm going to find the Fourier series in a full range. Solution: this is my formula for the Fourier series, and this is my function f of x. Now I'm going to find the values for a sub naught, a sub n, and b sub n, where the value of a sub naught equals to 1 over 2 pi times integral of pi minus x to the whole square over 2 dx, with a range from 0 to 2 pi. Take 1 out outside of the integration. Now I have 1 over 4 pi times integral of pi minus x whole square dx. Take integration of pi minus x to the whole square to have pi minus x to the whole cube over 3 times minus 1. When you expand the limits, you will get finally this is my a sub naught. Now from a sub n, which equals to 1 over pi times integral of pi minus x to the whole square over 2 times cos nx dx. Take 1 out outside of the integration. I have the product of two functions. One is the algebraic function and the other is the trigonometric function. So I'm going to do the integration by parts process here. Normally we use this formula to do the integration by parts, but since I have one algebraic term which is pi minus x to the whole square over 2, and therefore I'm going to apply the other method. Let me put differentiation at left side and integration on the right side. Put the algebraic term under the differentiation process. I just take pi minus x to the whole square because I took 1 out outside of the integration. Put the trigonometric function under the integration panel. Derivative of pi minus x to the whole square equals to 2 into pi minus x times minus 1. Integration of cos nx equals to sin nx over n. Derivative of this term equals to minus 2 times minus 1. Integration of sin nx over n equals to minus cos nx over n square. Derivative of this term equals to 0. Minus cos nx over n square equals to minus sin nx over n cube. I stop the process here because I got 0 for the differentiation panel at the end. So the time when you get 0, you're gonna stop the process. I'd start from minus here and then plus, minus, plus. Take cross product here between the terms, which equals to pi minus x to the whole square times sin nx over n. Minus 2 into pi minus x times cos nx over n square minus 2 into sin nx over n cube. Put the limit 0 and 2 pi where all the sine terms are 0. So I only left with cos n 2 pi and cos n 0, where cos n 2 pi equals to 1 and cos n 0 is also 1. Simplify the equation and finally I have 2 over n square. This is my final value for a sub n. Now take b sub n, which equals to 1 over pi times integral of pi minus x to the whole square over 2 times sin nx dx. Take 1 out outside of the integration to have 1 over 2 pi times integral of pi minus x to the whole square times sin nx dx. So I have the product of two terms here. One is algebraic term and the other is the trigonometric term. So I'm going to apply the integration by parts process here. Since I have one pure algebraic term which is pi minus x to the whole square, so therefore I can apply the differentiation in integration process. Put differentiation at one side, integration at another side. Take the algebraic term under differentiation panel and trigonometric term under integration panel. Derivative of pi minus x to the whole square equals to 2 into pi minus x times minus 1. Integration of sin nx equals to minus cos nx over n. Derivative of this term equals to minus 2 times minus 1. Integration of minus cos nx over n equals to minus sin nx over n square. Derivative of this term equals to 0. Derivative of minus sin nx over n square equals to cos nx over n cube. I stop the process here because I got 0 at the end for the differentiation panel. Start from minus, plus, minus, plus. Take cross product here between these terms, where finally I have minus pi minus x to the whole square times cos n x or n, minus 2 times pi minus x times sin n x or n square, plus 2 times cos n x or n cube. Put the limits which are 0 and pi, and I left with all the cos terms, which are cos n 2 pi and cos n 0. Cos n 2 pi equals to 1 and cos n 0 is also 1. Simplify the equation further. At the end you will get b sub n equals to 0. This is my value for b sub n. Now substitute the value of a sub naught, a sub n and b sub n in this formula here. Just put here. These are the values of a sub naught and a sub n. B sub n is 0 here. Simplify the equation further. I'm gonna put some random values for n. If I put the value of n equals to 1, this term gonna be plus 2 cos x. Put the value of n equals to 2, this term will be plus 1 over 2 times cos 2x. Put the value of n equals to 3, this term will be plus 2 over 9 times cos 3x. And put the value of n equals to 4, so the last term will be plus 1 over 8 times cos 4x plus infinity. This is my final Fourier series for the function pi minus x to the whole square over 2, which is defined in the interval from 0 to 2 pi. It is an example of full range Fourier series.